Hello friends, welcome to ML with AP. The topic for today is descriptive versus inferential statistics. Even before that, let's try to understand what a statistic is. If I have to define a statistic in one plain, simple, layman sentence, then I would say that a statistic is a branch of science, a branch of mathematics, which deals with data. Now, what sort of data and what do we do with data? If we are collecting data, organizing data, analyzing data, interpreting data, or presenting data, what we are doing? We are doing a statistics. Okay, just to recap, if you are doing a data collection exercise, if you are doing a data analysis exercise, if you are interpreting data in some form, if you are presenting data in the form of pie chart, bar chart, histograms, you are doing a statistics. With that being said, let's try to see what is descriptive, what is inferential statistic, and what is the difference among them. So when we talk about descriptive statistics, we are talking about the visible characteristics of the data. What is visible characteristic? Let me give you an example. Let's say we have a set of 10 numbers, 10 integers. The average of those, in terms of statistics, we can call it arithmetic mean. That's the visible characteristic of the data. That's where most of the data is lying. That's how the average is defined, right? That comes, if we are doing that sort of analysis, that comes under the scope of descriptive statistic. When we call about inferential statistics, then if you are making predictions out of those data, if you are making generalizations, then that thing falls under the bucket of inferential statistics. Let me give you a few examples and it will make much more sense. In case of descriptive, if you are calculating, let's say, mean, median, mode type of thing, standard deviation, variances, if you have heard these terms, fine. Otherwise, I'm going to deal these topics in detail in later videos as well. If you are doing plotting a bar graph or a histogram, right? Those are the ground truths. Those are the visible characteristic of the data, right? It is not going to change. We are not doing a probabilistic analysis on that. We are not predicting something. This is what the data is being represented. That falls under descriptive statistics. While on inferential statistics, let's say we have 10 numbers, and if somebody asks you to predict the 11th number, how will you do the prediction? You'll use probability to make prediction. You'll use some statistical tools to make those, right? If you have friends, you have heard about the terms like hypothesis testing, confidence interval, regression analysis. These things fall under inferential statistics. So in summary, if we are dealing with the ground truth or the visible characteristics, those fall under descriptive. If you are making a predictions, making a generalizations, and based on a small sample of data on a larger set of data, that is called inferential statistics. Let's try to understand it with an example. And what better example than the pandemic we are just out of. So this is the data which I have taken from WHO website. It's about the vaccine called Covaxin. This is the same vaccine which incidentally I also got. So I was seeing that, okay, what is the efficacy? Efficacy is that what is the percentage of people on which it has a positive impact. So it appears that under the age of 60, the efficacy of Covaxin vaccine was 79%. Now, how did they arrive at that figure? I dig deeper. So it seems that Bharat Biotech has published this data in their phase 3 trials. Now, these drug companies do multiple trials for a particular drug. So in the phase 3 trial, Covaxin was tested on or experimented on how many people? 25,800 volunteers. So this 79% efficacy was gathered on 25,800 people. So in other words, they tested this vaccine on initially during their phase 3 trial on 25,800 people. Out of those 25,800 people, 79% had a positive impact. They got better or they were cured or something like that, right? Now, this 79% efficacy is a ground truth, is the visible part of the data, right? So this will come under descriptive statistics, okay? Now, what will come under inferential statistics then? Then I dig deeper and I saw this number that Covaxin in India till December 2022 was administered on 36 crore people. If it was done on 36 crore people, and if somebody asks you a question that, hey, what was the efficacy on these 36 crore people? Is it a simple exercise to get that answer? No. We can't go and interview 36 crore people. We can't gather the data for 36 crore people. What statistician, what the people who are researcher or people related to stats will do? They are going to make some predictions, some assumptions, okay, using some statistical tools, and they will come up with some number that, okay, on 25,800 people the efficacy was 79%. If we do it on a larger population, on a larger set, which is 36 crore in this particular case, it may be around 72%, give or take 5%, plus minus 5%. Now, why do we always do this plus minus 5%? Because it's a prediction. Inferential statistics is all about prediction, and they can't be 100% sure that on 36 crore people it was at 72% or 75% or 79%. They will give you a range that, okay, I think the efficacy was lying between low range as this and high range as this. And how they will do? They will use inferential statistics. So friend, I hope with this example it is clear that what falls under the bucket of descriptive and what falls under the bucket of inferential statistics. Just to recap, this 79% which was done on 25,800 is a hard truth. That's on descriptive side. On the whole population, if we have to measure the efficacy, and efficacy comes out, I'm just making this number, efficacy comes out some 70 to 73%, give or minus, plus or minus few percentages, right? That comes under inferential statistics. With that being said, let's move on. You'll keep hearing these terms, population versus sample, if you are dealing with statistics, right? What is population and what is sample? In our previous example, population was this 36 crore people. Sample was 28,500. Sample is a small subset, okay, on which typically we run the experiments. And then we try to make the prediction about the population. Why we can't do the experiment on population itself? The answer is very simple. If you do that, it's a very costly affair. It's a very time-taking affair. Let's just, in our previous vaccine example, just assume that the data of 36 crore people, whether they were cured by Covaxin or not, it's not an easy thing to get. That's why we deal with sample and we try to make a prediction about population. Population is when we talk about the whole data set, the entire data set, 36 crore people, that is population. Sample, a subset, 28,500 people. Why we do not use population? It's costly and time taken. Sample, when we are taking sample, we have to be very careful that the sample has to be representative of the population. It should depict what the population is comprised of, and we'll just take a moment later to dig it deeper. Examples, in what are the situations where actually we can deal with population? If let's say your data size is very small. If I have to give you an example, just assume that in a class, the class teacher is trying to assess the maths performance. Then he or she has taken a test, and in the class there are 30, 50 or 100 people, right? 100 students. It's very easy to do an analysis on top of that, right? In that case, we'll take the entire class. In that case, the class will become a population, right? Those 100 students. And when we deal with that, in those sort of scenarios where the data size is small, we can deal with population. Rest 99% of the cases, you will not have the population data. You will not have population metric. What you will have is sample. Let's say company revenue growth. So company already had the data for all the customers, all the invoices which has come in, right? All the purchase orders which has come in. So they can exactly produce their revenue growth, okay? In those situations where the data set is small, we can play with population, okay? In case of sample, okay, so what are the examples of samples? Samples are like, if we are doing surveys, those are samples. Why we are doing surveys? If a marketing company is launching a new product, they do market surveys, right? Either they hire somebody, some agency, or they go to the market themselves and they ask various consumer groups that, hey, whether you like this product, what should be the pricing, and various questions they will ask, right? Exit polls, whenever the polls happens in India, we see that all the pollsters, right? The agency who does these exit polls, they will go from constituency to constituency and they will interview people. Why do they do it? Again, this is a small sampling technique, right? And why do they sometimes get it right and sometimes not? If their sampling techniques is right and if they have done their work, they will predict the exact outcome of the election. But if their sampling techniques are wrong, they will not be able to predict. Okay, vaccine efficiency we already talked about. Okay, so this is the difference between population and sample. Let's take another example to understand this whole concept of descriptive versus inferential and sample versus population. Census of India. Now, Census of India happens once in every 10 years. It happened in 1991, 2001, 2011, 2021, etc. Right? Census is done on population. So, whether it's a descriptive statistic or inferential, it is a descriptive because census is done on the entire population of India. But let me ask you this. If somebody comes to the question, census was done in 2011 and somebody asks you the question that, hey, can you tell me the literacy rate of females in India in 2019? Now, in 2019, there is no such survey which has been done, no such census which has been done. How you will predict? Now, here you have to do predictions. How you will predict? You will take a small sample which is representative. And then you will see from 2011 to here what kind of growth we had. You will do some sort of regression analysis to predict the population of female literacy rate in India. You will try to estimate that. You will try to predict that. That falls under the bucket of inferential statistics. Now, I have talked about sampling techniques. Now, sample we should have two properties. It should be representative and it should be random. What do I mean? Let's take one at a time. When we say random, let's take for example this census question. Okay, if we are not sampling randomly, what could go wrong? Think about it. Okay, somebody has been assigned this task and he's taking a small sample. Let's say if he has taken sample only from upper middle class and rich neighborhoods, what will be the literacy rate over there? We know the literacy rate goes higher with the income levels. Okay, that is the truth. If that sampler or the surveyor is only doing it in the upper middle class neighborhood or rich neighborhood, he will get a higher than expected figure for the literacy rate. That's why sampling should be done randomly. The second point is representative. Why it should be representative and what does it mean by representative? Representative means it should have all the properties what is there in the population. So India, let's say if you are trying to predict the literacy rate of females in India, you should not only go to, let's say, Kerala, where the literacy rates are very high, but you should also go to some parts of Eastern India where female literacy rates are still low. It should be representative. You should cover all the sections of the society in that proportion. That what is being called as representative. Okay, and it leads to, like, if you do not do these things, it will have some sort of biases. Okay, so this over here again, when we continue with the Census of India example, this is the bigger circle which you are seeing, the green circle, is all the girls in India in 2019. That is called the population. What we are taking, let's say we are taking a sample of 1 lakh girls, 100,000 girls, right? So our sample size becomes 100,000. And then we are making a prediction. We are doing an inferential statistic on that. And the prediction will always be in terms of a confidence interval. It will not be exact figure. Why? Because it's a prediction. Okay, and there will be some sort of margin of error over there. So let's say I'm just making this up, that this came at 70% plus minus 5% based on the analysis. Now, if this 1 lakh people, let's say, okay, even before that, answer these questions. So literacy came 70% plus minus 5%. Is this parameter or statistics? Now, if we are dealing with population, you always get parameters. You call it parameter. When you are dealing with sample, you call with statistics. Now here, what we are dealing with sample, and we got this data from the sample. So it will be a statistic and not a parameter. Okay. Now let me ask you another question. If suppose this 100,000 or 1 lakh girls, I'm doing a sampling of, let's say, 50 lakh girls, I increase the sample size to 50 lakh. Will my accuracy increase over here? Yeah, of course it will increase. The bigger the sample size, more representative it is, and less bias it has, better results you are going to get, right? Now, figure on the right, on the top right side, if you see, and this is a nomenclature. So if you are dealing with sample, you are dealing with, we are calling it a statistic. If you are dealing with population, you call it parameter. So let's say you are calculating the mean, and we are going to talk about in subsequent videos also. If you're talking about mean, in case of population, it is represented as x bar. In case of population, it is represented as mu. These are just the nomenclature which we are going to deal with. Similarly, for standard deviation, it is small s and sigma. Sigma is the Greek letter sigma over here, but we'll deal with that. Now, coming back to descriptive statistics, there are essentially two things which we talk about in descriptive statistics. One is central tendency and the other is dispersion. These words themselves represent what they mean. Central tendency, if we have a bunch of data, let's say 10 data, central tendency talks about that, hey, what is that particular number which accurately represents as the center of this data? Okay, let's say we have number 1 to 10. The center of data would be 5, right? Somewhere around 5. So that's what it is trying to figure, and it tries to figure out in various ways. So we can get mean, and there are various type of means also. We'll learn about that. Median and mode, these are essentially the central tendency. These try to figure out that where mostly the data lies, like what is that single point where if I give that point, somebody can get the idea that okay, most of my data is surrounded around that, right? So that's what central tendency is. What is dispersion? Dispersion is nothing but the spread of data. How wide a spread my data is, or how narrow a spread my data is. And there are various techniques for to arrive at that numerically in a quantitative way. We derive variance, we derive a standard deviation, range, quartiles, skewness, kurtosis. All these are related to dispersion of data. Okay. And there are two other topics which I'm going to discuss again in subsequent videos, which are related to outliers, how to detect outliers and all. Okay. With that being said, I think we have come to the end of this session. I will see you next one, and we'll be discussing mean over there.